an adiabatic, and I'm going to obviously move through all of these things in as much detail as what I possibly can. But adiabatic means that, remember what I said there, that there's no heat that's added or there's no heat subtracted. So in other words, there's no work done. And you only do work when you are expending kilojoules. Not so. If you don't expend kilojoules, you're not doing any work. So what happens over here is that any work that is done adiabatically is just going to maintain whatever enthalpy it started off with. So in other words, if we do adiabatic cooling or adiabatic heating, we are just going to go on the line. If we had to move, say for argument's sake, we had to move like that, what would happen? The beginning point over there is up there in terms of about 72 kilojoules per kilogram. At this point over here, where we end, it is going to be 62. So in other words, that is not adiabatic because there's been a change. There's been a change in the enthalpy. But in this particular case over here, point 1 started at 75 kilojoules per kilogram, and point 2 was still at 75 kilojoules per kilogram. Okay, so now, if we've got to look at sensible heating. Sensible heating would take place, and this little sketch that I'm going to give you over here is just one that I always use. And it just is it's a diagram to depict what takes place in an air conditioning unit. First of all, we've got an inlet over here. That inlet is where the fresh air is taken in. Fresh air inlet over there. We have a valve, and that valve is just so that we can control the amount of fresh air that we're taking in. On this side over here, we've got an exhaust, because after a time, if we circulate air long enough, we're going to find that the air is going to become exhausted, or the oxygen is going to be depleted, because people are breathing it in, and there's going to be an excess of carbon dioxide. People are going to start getting tired. If it persists any longer than that, people are going to die. So what we do is we exhaust. We exhaust some of the air out. So it just maintains a fresh flow of air over here. So this over here, we're going to say this is like the conditioned space. The conditioned space refers to your room or your auditorium or your theatre or your cold room, all of those other things. That's a conditioned space. Now, what we invariably have is we've got to have a fan, because we've got to move the air, and sometimes they got two fans, sometimes they got a fan over here, sometimes a fan at the top, only in one. Depends on the size of the unit. If it is a very big unit, you'll have a fan over here which is sucking, and you've got another one that's blowing. The next thing we're going to have is we're going to have, so okay, so let's indicate that as the fan. Okay. The next thing we're going to have is the coil. Okay. Now this coil cooling coil is fed with a lot of cold water. Remember, I dealt with primary and secondary refrigerants the other day. Sometimes the coil is a direct injection, which means that the refrigerant is running directly in that coil and it's cooling the surface. Or sometimes you will run water through it or brine through it that has been chilled. But whatever happens in that particular case, if it's direct injection or if it's not direct injection, whatever air that is now flowing in this direction flows through that cooling coil. And what happens is that the heat that is in the air, as well as the moisture that is in the air over here, will now be treated as it comes through this coil. As the air and vapor mixture moves through here, the heat, that is the sensible heat that is inside of the air, will be given up to the cold surfaces of that coil. So what comes out on this side over here is going to be cooler. The other thing is that the amount of moisture that is in the air, as the moisture hits the cold surfaces of the coil, immediately the moisture will then start to condensate. So in other words, it would form droplets of water. It would adhere to the surface of the coil, and invariably it would drip out over here. And it's that particular process you'll always see from your household air conditioners. So in other words, you switch on your air conditioner at home on a hot day, and you go and stand outside, and invariably outside there's a pipe that comes down from the unit, and you will notice that water starts dripping out of that pipe. And that water that is dripping out of the pipe is the moisture that has been shed from the air moisture mixture that goes into the coil, and then that's on the outside. You will notice the moisture dripping out. If you go inside your house and go and put your hand in front of the vent where the air streams out, you'll find that that's cold. So that's technically what happens over the coil. Now, behind the coil, if it is a very cold climate, what would happen is that they would put in an element. Some of the units or some of the installations, they sometimes use steam through the coil to actually effect heating in the winter. We're not going to be too perturbed about that. I'm just giving you a very simple one over here, in which we're just going to be putting in a bank of resistance elements. So in the winter, we obviously not going to pump any cold water through this thing. We will switch off that system altogether, and we will turn on the electricity onto this element, and that would then heat up, and it would then heat up the air and so in other words, it would warm up this area. Now, the last thing that we add in over here is that sometimes when we heat air, if we're heating air, we find that especially in winter, where there's very little moisture or very little water vapor that is in the air water vapor mix, what happens is that the air is very dry. So people working in this area over here land up with dry throats, and they find that the skin gets very dry and it becomes uncomfortable. So what we've got to do sometimes is that we've got to we've got to add in a bit of moisture, a bit of humidity, just to bring it down to an acceptable level. Now, acceptable level in terms of humidity and or sort of like a good combination of sensible heat and humidity for any condition space is about 22 degrees Celsius and 50% relative humidity. So if, for argument's sake, we've got a very dry winter and we find we only got 30% relative humidity, what we do is we actually add sprays in over here, which spray water down. Sometimes I have a water curtain, so in other words, it's just a sheet of water that the air draws through, and as it draws through there, it will pick up humidity. So the heat, the sensible heat, will be sufficient to draw humidity. So what happens, there'll be a slight decrease in the temperature on this side of here because of the amount of some of the heat will be given up to the water. But we will ignore that slight decrease in temperature, and we'll say that to all intents and purposes that the temperature going in is the same temperature coming out, but it's coming out with humidity added to it. So in other words, we could say that we set our element to give us 22 degrees Celsius, which it does, and then the humidity or the sprays or the water curtain over there then brings up the humidity to 50%, which gives it a decent air-conditioned climate in there. In some places where it is very, very cold, okay, so let me just put this as a humidifier, okay? I'm going to put the correct word. Correct humidifier, that's a humidifier, that section there. This is the element. That one is the element. Here's the element. Here's the humidifier. Here's the fan. Here's the cooling coil. Here's another fan. Exhaust. Fresh air inlet. Okay. I sometimes like to just in a test or something, just throw this thing and just say, listen, name the parts. You've basically just got to tell me what it is. Okay, now the air flows like this. Comes along here, through there. Some of it would go that way. The rest would come up here. You'd have air coming in and then coming back to the air-conditioned space. Okay. This point over here is always going to be, I'm going to write it in red. That point is always going to be point number 1. This return air over here, it's return air, so that coming in is point number 1. This return air is always point number 2 on your chart. Where it mixes over here is a very crucial spot. That is point number 3. And then straight after this coil over there, point number 4. Okay.